Hello students, once again welcome to my channel. So hope you are ready with your pen and paper whenever you are watching any numericals or any physics lecture, maths lecture, chemistry lecture. Always keep your pen and paper ready. Note down all the subject. It would be even better if you note down everything on chapter wise from the very beginning. Be organized, be systematic from very beginning. It will help you a lot at the last moment. It will help to manage your time. It will help save your time. So keep everything systematic. Keep everything in written form. It would be better to write everything chapter wise. So theoretical, numerical, keep everything for every chapter at one notebook. It will save your time a lot. So coming to the first question, all these are from Thermodynamics, Neet and AIMS 2017. This question is, argon gas is at 20 degrees centigrade. If the gas is expanded adiabatically 8 times to its initial volume, find the final temperature of argon gas. So first find out what is given, then what to find out. So it is an argon gas, it is a temperature T1. So temperature T1 is 20 degree. Whenever it is degree centigrade, always convert it into Kelvin. 20 plus 270, 293 Kelvin. Gas is expanding adiabatically, so it is a adiabatic process. It is a adiabatic process, and adiabatically expand 8 times to its initial volume. So if initial volume is V, final volume is 8V. So find the final temperature. Very easy question. So adiabatic process, temperature volume relationship. So for what is the relation for temperature and volume in case of adiabatic? That is V, that is T1 or TV gamma minus 1 is equals to constant. From this you can write T1 upon T2 is equals to T1 upon T2 is equals to V2 upon V1 gamma minus 1. Now just put the values. T1 that is equals to 293, T2 that to find out V2 upon V1, that is final minus initial, that is equals to 8 to the power gamma minus 1. This is an argon gas. So what is gamma for argon? For argon, gamma will be 5 upon 3. Monoatomic gas, so that would be 5 upon 3. So that means T2 is equals to 293 upon 8 gamma. Gamma is 5 by 3 minus 1. 5 by 3 minus 1 is equals to 2 by 3. So that is equals to T2 is equals to 293. This you can write 2 cube. 8 is 2 cube. 2 by 3, that is 2 square 4. So this is 293 upon 4. That is equals to how much? So this is in the form of Kelvin, 73.25 Kelvin. So 73.25 Kelvin, to convert it into again degree centigrade. So this is Kelvin. All the answer is in your degree centigrade format. Whenever question is very easy, so just go for the units. You may be tricked from units if the question is found to be very easy to. So it is Kelvin. The answers are all in degree centigrade. Again, this you need to convert into degree centigrade. Kelvin. So minus 273 minus this is minus 273. The answer would be minus 200 degree centigrade. Okay. So just note it down. Then let's go to the second question, which is, an ideal gas at pressure P undergoes free expansion from initial volume 1.01 liter to 10.1 liter. Then find the final pressure of the gas. Again, an easy question or question given. It's an ideal gas, initial pressure P undergoes free expansion, initial volume is given, final volume is given. So need to calculate the final pressure of the gas. So it's a adiabatic free expansion. Free expansion means what? A system is going for free expansion. That means no heat is entering to the system since it is getting expanded. So neither heat is getting inside nor heat is coming out of the system. So del Q is equals to 0. Change of heat is 0. So it is a adiabatic process. So process is adiabatic. Initial volume is given. Initial volume is how much? That is equals to 1.01 liter. final volume is given, that is equals to 10.1 liter, and it is an ideal gas adiabatic process. Initial final volume is given, so which relation we are going to use, that is equals to PV gamma is equals to constant. That means P1 V1 gamma is equals to P2 V2 gamma. So P1 is equals to, suppose P, initially at P, V1 is 1.01 gamma is equals to P2, that we want to calculate. V2 is 10.1 to the power gamma. So that implies P2 is equals to P 1.01 upon 10.1 upon gamma. This get cancelled, 10. So this is P upon 10 to the power gamma. 1 to the power gamma is 1. So down 10. So 10 to the power gamma. So P upon 10 to the power gamma. Now the last question. Hope you are able to note it down. Then the last question. A Carnot engine having an efficiency of 1 by 10 as a heat engine is used as refrigerator. So just focus on what the question is telling. It's a Carnot engine which is an efficiency of 1 by 10. So your efficiency is 1 by 10. Now it is used as a refrigerator. If work done on the system is 10 joule. So given work done is 10 joule. Then found the amount of energy absorbed from the reservoir at lower temperature. So whether it is a heat engine or refrigerator, there are two sources of heat. One is hot reservoir, another one is sink. This one is maintained at very high temperature, this maintained at lower temperature. In between there is a working substance. So in Carnot engine or heat engine, what is happening? Heat is flowing from hot to higher to lower range, and in between your work is done. That is efficiency of a heat engine, is how much work is done upon the heat absorbed from the source, that is which is maintained at a higher temperature. But in case of refrigerator, what is happening here? Heat is transferring from, you are extracting heat from the source by doing some amount of work. Suppose in case of your refrigerator, it's a compressor which is doing work to extract heat from the sink, which is maintained at a lower temperature. So here your efficiency of the refrigerator, that is equals to Q, suppose it's the cool, hot or cool. So QC upon work done W. What is the work done? Work done is always the difference of the heat between sink and the source, that is QH minus QC upon QH. This is for the hot reservoir, this is for the cold reservoir. Now this is equals to how much? QC is equals to QC upon W, that is equals to QH minus QC. So you need to find out a relation between alpha and eta, because eta is given and W is given. So you can find out QC, that is what is the heat amount of heat absorbed from the reservoir that is maintained at lower temperature, that it is meaning the heat of the sink. So you need to find the relation between eta and alpha. So eta, it is in the form of QH minus QC upon QH. Here it is upon QH minus QC. So if we'll do like this, QC upon QH divided by QH minus QC upon QH, because I want to convert it in this format to get the relation between alpha and eta. Now here you get a form, this in the form of eta, QH minus QC by QH. Again it is in the form of QC and QH. This term is extra, so again need to convert this into in the format of eta. So what will you do? Just add 1 QH minus QH plus QC upon QH minus QC upon QH. So if we'll see, this will come as 1 minus eta divided by eta. Check whether it is correct or not. Eta is QH minus QC upon QH. Here minus QH plus QC is there, so minus sign is given. QC minus QH upon QH, that is minus eta. QH upon QH, that is 1, divided by QH by QC upon QH, that is eta. So problem is solved. Now what is given? Eta 1 minus eta is 1 by 10 upon 1 by 10. This is equals to 9 by 10 upon 1 by 10, that is equals to 9. So you got alpha is 9. Alpha is 9. What you want to calculate? Find the amount of energy absorbed from the reservoir at lower temperature. That means you need to find out QC. How much amount of heat you are absorbing from the lower temperature, from this sink. Here, that is QC value you want to find out. Now alpha is given, that is equals to 9. And you want to calculate this QC value. Work done is given, that is equals to 10. So here you can say that 9 is equals to QC, which you need to find out. Then work done is 10 joule. So QC is equals to 90 joule. So this is the answer. Hope you have note down everything. If you have any doubt in this question, or if you have any unsolved numerical, you can send it to me. Details are given in the description box, and you will get your answer absolutely free. You will get your all answer absolutely free of cost. Thanks for watching my videos.